some very quick example of injective and surjective functions. So today we want to look at example one. Example one is a function that has a domain of real number and a codomain of real number, and our fx is equal to 1 over 1 plus x squared, right? So is this injective or no? Well, clearly not, right? Because let's say our x let's say our x is equal to 2, okay? What does that give us? Well, that gives us f of 2, which is 1 over 1 plus x squared, which is 1 over 1 plus 2 squared is 4, right? What if our x is negative 2, right? Well, f of negative 2 is equal to 1 over 1 plus x squared, and negative 2 squared is 4. So as you can see here, it shows why that is not an injective function. Because although we have the same output, but we can have like different input value to give a same output, and that violate our definition of an injective function. Because it's like if I were to do it in the old way, it will be like this. It was saying that 2 and negative 2 both connect to 1 over 1 plus 4. And this is wrong, because I already shown in my last video that this contradict the definition of an injective function, as it can only be 1 to 1. Like in the case where if there's only 2 that produce 1 over 1 plus 4, it will be injective, or negative 2 produce 1 over 1 plus 4. But you cannot have 2 and negative 2 producing the same value. That will be violating the definition of an injective function. So it's not injective. What about surjective, right? Well, it's not surjective either, because look at this is some you gotta look at the detail of our codomain. Our codomain says is that because in a surjective function, what matter is the codomain. In this case, our codomain is all real number. But as you can know, if you look at our function, f of x is 1 over 1 plus x squared, right? This can never be negative, right? Because for any number that you put in, any real number that x that you put into this function right here is always going to produce 1 over some positive number or something like that, but it's never going to be negative. But our codomain is all real number, and all real number includes negative. So therefore, it's not surjective. Not surjective. Because, right? Because it can only produce positive number, but our codomain says that negative number are element of our codomain as well. Well, then those negative number doesn't have a corresponding input value, right? So therefore, it's not surjective. What about in the next case? In next case, we said that our function g has a domain of a natural number and a codomain of natural number, and our function is at n's cube plus 1, right? So is this surjective? Well, this is not surjective, because say what's the smallest natural number? Say the smallest natural number is of course 1, right? So let's say our n is equal to 1. Well, if I plus n into this our equation, 1 to the cubic plus 1, it's gonna give us 2. And as you can see, there's no way that you can ever produce 1 as our result of our some kind of input value, right? Because the smallest number that you can fit into our function is 1, and that it doesn't give the value 1, but the value 1 is in our codomain, because our codomain include all natural number, right? Because our codomain include all natural number that goes from 1 to infinite, right? But it cannot include 1. So therefore, not every element in our codomain has a corresponding element in our domain. In this case, it's 1, right? Because in this case, you can never get 1. You can never obtain 1 as the output value, no matter what input value you give it in. So, but 1 is also part of our codomain, right? So there's a number, or there's an element in codomain, a natural number that we cannot obtain through plugging any input number. So therefore, it's not surjective. What about injective, right? Well, however, this is an injection. Well, that's right. It's like this is and injection. Sorry. And our injection, one of the injective definition is that if f of x1 is equal to f of x2, right? Then x1 must be equal to x2. You cannot have like that x1 is f of x1 is equal to f of x2, but the both input value are different. That violate the definition of injective, and that's very intuitive, right? Because our injective whole point of injective is that it's 1-to-1. It's like each x element in domain has a corresponding element in codomain, right? So if f of x is equal to each other, so if f of x1 is equal to f of x2, then x1 must be equal to x2. Because if it's not equal to x2, like in our first example, where see our f of x value are same, but x1 is not equal to x2, is not injective. So this definition kind of work. So we can kind of go from this definition, right? So let's say so let's say that if m1 is not equal to n2, right? Our two natural number, then n1 cube is not equal to n2 cube, right? According to our definition, which implies, wait, I forgot to imply that, n cube 1 plus 1 is also not equal to n cube 2 plus 1, right? Because n1 and n2 are essentially different. I assume this, right? So they're not the same. Then this implies that gn1 is not equal to gn2, right? And this satisfies our definition, because what we did here is that we assume that we have two natural numbers that are not equal to each other. We assume based on that fact, and then we at the end we prove that if we started with this, let's write different number, then our result give us different output, which is the definition of injective, right? Because if I have two value, x1 and x2, and they're not equal to each other, if I plug it in to our equation, they're not is not going to give me a number that is equal to each other, right? Because if it does, it's not injective. So it's satisfied. So therefore, I kind of prove that our function here, gn is equals nq plus 1, is a injective function, but not a surjective function. And those will be two quick examples for as our injective and surjective and bijective. I'm gonna do a video on bijective example in my next one. So if you like this video and think you learned something, please consider subscribing.